Section 2.1, radical functions and transformations. So this is exactly what we learned in chapter 1. It's just using it with a different graph. So we're just doing radical equations now. So that just means equations with roots. So we don't have negatives in these situations because you don't have negatives under roots. Okay, so this is our standard, oh boy. This is our standard equation. Gotta get my pen going. And this would be a table with it. Okay, so if I plugged in 0 for my x under the root of 0 is 0. If I put 1 under the root of 1 is 1. Okay, if I put 4 in for my x, the root of 4 is 2. And if I put 9 under the root of 9 is 3. So this is where my standard table comes from for my graph. Okay, if I was to graph this, I have 0, 0, 1, 1, 4, and 2. Okay, and it starts to look like that. So, if we have an equation that looks like this, we now know, what does that minus 2 after mean? It's not under the root with the x, it's hanging out behind. So what would a negative 2 behind there mean? And so, what kind of translation is that? Is what my question is. Okay, vertical translation 2 down. So then, it just means all our y points, you're subtracting 2 off of. Right? So then our picture, instead of being at 0 and 0, it would be at 0 and negative 2. Instead of being at 1 and 1, it would be at 1 and negative 1. So our picture just shifts down 2. And then instead of 4 and 2, we're at 4 and 0. So this would be our new graph. Okay, and same goes with this. Root x minus 3, what happens in that situation? Yeah, it's just moving your graph down 3. Okay, so then you'd just be subtracting your points by negative 3. Yep. The original, because we're always going back to the original. Okay, so these graphs are learning nothing different, right? It's just taking a radical equation and it is applying the translations that we already know how to do onto them. Okay, on the second page of your notes, I'm just going to add a page here. You guys have a standard root equation, and it has all the possible pieces with it. Okay, so this works the same as it did in the last. So if we have an a out front, that is a vertical stretch. If a is negative, then that means that we have a reflection on the x-axis. So we're not learning anything new here, it's just in a different kind of equation because it has a root. But it's the same thing. Okay, so for B, this is a horizontal stretch. Okay, and remember, if this B was 4, that means your picture is a quarter of the size. If this B was a half, that means it's twice as big. Whatever's happening inside under the root is actually opposite of what's really happening. Okay, so if B is negative, then it's a reflection on the y-axis. Okay, our H is our horizontal translation. So a negative is to the right. positive is moving left, and our K is a vertical translation. Positive up, negative down. Okay, example 2. Said sketch the graph of each function using transformations, compare the domain and range. So here is our equation, and we need to sketch the graph of this. So let's start with our usual points. Okay, so 0 and 0, because our usual table, as simple as it can get, is just root x, right? So 1 and 1, 4 and 2, and 9 and 3, because I'm just taking the square root of all my x's. Okay, so now, I don't know why the root's cut off here. That's supposed to have a root there, and right there. And I would add 3 just so it looks better. Okay, so in this situation, I have, what's that 3 there? Okay, so I'm going to do what? Y's by 3. Okay. Okay. Apparently they're just going over there. Okay, so I'm timesing all my x's by 3. And then what's this negative here? Right, so it changes all my x's to opposite. I'm going to put these back. Yeah, it's possessed. Just because I said that movie wasn't scary. Okay, so now my points. Remember, because we're always doing reflections and stretches first. So now I have 0, negative 1, negative 4, negative 9, and I have 0, 3, 6, and 9. Okay, and what's the last thing that I have to do here? And right, I'm adding 1 to my x's. So my new points are going to be 1, 0, negative 3, negative 8. Okay, and then all I do is graph my final points here. So 1 and 0, 0 and 1, 2, 3, 1, 2, 3, negative 3, and 6, somewhere over here. So our picture is going to look like, there we go. I know. Okay, so I'm not going to do the full second example here because it's all exactly the same. So all we need to know is we have a reflection on the x, and so that would change our y's all to negatives. This is a horizontal stretch of how much though? A half, right? And then we have, we're going up 3 for a vertical translation for that. Okay, and so we'd start with our normal table, and then we would do the reflection, the stretch, and then add 3 to our y's. Okay, so for our last example, come on. Example 3 says Maylene is designing a symmetrical pattern. She sketches the curve shown and wants to determine its equation and its reflection. The graph is a transformation of the graph of y equals. So our normal equation is just root x. What are the equations of the 4 functions Maylene needs to work with? Okay, so what happened to this picture? So if we look, remember our original points were always 0 and 0, 1 and 1, 4, 2, 9, and 3, right? And if we look at the points on this one, it is 0, 0, 1, and 2, 4, and 4. Okay, so what happened? Can you tell from these points? Yeah, it's a vertical stretch of how much? Yeah, it seems like we times our y's by 2. So our equation would actually look like that.